Hello, Teacher Dennis Monday Maximus, back with the physics for Senior 2. From Senior 2, some of you start practicals in Senior 2. But basically most schools start in Senior 3, so Senior 3, Senior 4, Senior 5 and 6. The concepts are just applicable to all. So, like we looked at some cases of manipulation of results in lesson 2. So I want us just to build up from where we ended, and in this case I want us to look at the main table of results. We call it main table of results. The main table of results. I'm abbreviating it as MTOR. It's not a standard abbreviation, it's mine only. So how do you design the table of results? This is what we want to look at. How do you add or subtract data in the main table of results, and then how do you multiply and divide data in the main table of results? Before that, we just need to know how we design the main table of results. Now, I will take an example of some questions here. Every time you are given a paper, this is clarified. This is one of the books under clarified physics for practicals. It is called demystifying physics practicals. So we have a number here where you are supposed to determine it. I think it was basically refractive index of water. Now, if you want to draw the main table of results, always look for the procedure which starts in this way. It says repeat. Repeat. Because whatever has to be repeated has to be in the main table of results. So the role of the main table of results is to help us represent in an organized way those values that are being repeated and the results thereafter. So here they said in this experiment you determine the constant alpha for water, measure and record the height h of the beaker. I'll look at examples where we explore a whole number, so don't worry about this. All I want you to know is look through, read until you find a procedure that says repeat procedures. So let me write it for you here and then you see. It was in this number, it was part I, and it was like this. They said repeat procedures. For those of you that already have this very workbook, this practical manual of physics, I know you can easily locate this. I think it is on page 73. If you don't have it, you can also get one. Yeah, but it's always good to buy in a group. A teacher can help to purchase and cheaply. Repeat procedures C to H. For values of y equals to 5.0, 6.0, 7.0, 8.0 and 9.0 centimeters. And then after that they said record your results in a suitable table including values of. Now before you record, I said if you want to know how to draw the main table of results, look for the procedure that starts with this word repeat. So we want to look for that procedure. We have identified it. For our case, it was here. So whatever has to be repeated. So you see, we were repeating values of y. That means in our table of results for that year, this was a unable number by the way, for that year, the first column we put values of y, and the units are always at the end in centimeters. Y in centimeters. Please you write properly. You really write properly. Students are fond of saying, now teacher, for you write properly because you're writing on the chalkboard. If these are the lines, please don't write y like this, y in centimeters. Others write y. And then the bracket and the centimeter, they are all the same size. So, how are you supposed to write? If this is the line, this is the line. This is the line where you're writing. So what you do is, assume as if there are 3 lanes there. You see that? 3 lanes. So if I'm writing a y, you know those writing books that they use in nursery? Just have that kind of assumption. In this small space here. So if you're writing a y, you write like this, and then it comes down this way. You see? It doesn't have to go into another line. And then in centimeters, like that. So you can, if it's a t, small t is like this. Small t. So life is going to be very easy for you if you write that way. Okay. So now our values, we are repeating from 5.0, 6.0, 6.0 up to 9.0. But remember what has to be repeated. You can't repeat what you've never done before. So they told us that we are repeating for values of y equal to these ones. So it means we first have to identify the first value before we started the repeating. You go back and read. Part C said pour water to a depth y equals to 4.0. It means that before the repeating, I had y equals to 4.0. Then you can now fill in these ones. 5.0, 6.0, 7.0, 8.0, 9.0. Hey, where? Okay. I had limited space. By the way, make sure when you're drawing the table of results, you have enough space. Otherwise, you're not supposed to draw it on one page and it continues into another page. No way. No way. We don't draw that. Okay. Then the other values, the values that you put next, they told us to repeat from C to H. So go back from C to H and read through. C said pour water to that depth. Part D said place the mirror. Part C said fix it. Okay, all I'm doing is I'm looking for a place where there is something to read and record. Part F said part G, part H. Now it's part H where they said measure and record the height X. Oh, please understand me properly. Don't mistake what I'm saying. If we want to draw the main table of results, start by looking for the procedure which starts with the word repeat. And then go up to the end, you realize the quantity which is being repeated, here it is y, and the units are at the end. That's why I wrote and said y in centimeters. Then after that, now go back and read those procedures which are being repeated from C to H. And in that interval, whatever has to be measured and recorded has to be replicated here. You have to reflect it here. So, here, what was being measured was in H, part H, which was X. X, and definitely because I'm measuring X using a meter rule, I have to write it in centimeters to 1 dp, 1 decimal place in centimeters. So here, you represent like that. Then many times they will tell you, including values of. So they will say, part J actually said, record your results in a suitable table, including values of H minus Y. Hey. So we shall need H minus Y. In the second video actually, we said if you have H minus Y, you put a bracket and the units also in their own bracket, like that. Then we have also and Z, which is equal to, they want us to include the value called Z, which is equal to X minus into brackets H minus Y. This question was set in paper 3, 2016. I have remembered paper 3, and it was number 2. Yes, number 2. So they want us to include the value of Z. Please the reason why they gave you this letter is for you not to write all these things. Huh? So you also write a Z. You write a Z. Unfortunately, my space is done here. My space is done. But let me represent that one more time. We had the Y starting. Y started in centimeters, and we obtained values of X in centimeters. And now they asked us to get values of H minus Y. That was also in centimeters. And finally, they are asking us to get Z in centimeters, like that. Oh, I'm trying to utilize this small space here. But don't worry, we shall have cases where we'll explore everything. So we had from 4 up to 9, 5, 6, 7, 8, up to 9. That is our table of results. And the table of results doesn't have to touch the margin, eh? Please, this one was just a coincidence, like it has to be on its own, like that. Yes, so how do you design the table of results, the main table of results? You design it, number one, it has to be columnar. So our first case here, part A, I want you to know that the table of results has to be, the main table of results has to be columnar, in columns. So it has basically, it has two, it is in columns. It can have as many columns as possible, but only 2 rows. So there is the first row which carries the titles, the quantities and their titles. For example, you may have X in centimeters, you may have T in seconds, like that. So those are different columns. Then you get capital T. Capital T has to be equal to the bracket, capital T, like that, in seconds, T squared onwards. So the main table of results, I repeat, the main table of results has to be columnar. It has to be columnar, and don't make different rows. There are only 2 rows. The first row is for the titles, physical quantities, and their titles, their units, sorry. Quantities and their units. In brackets, we put the units. Please don't use the stroking, X stroke centimeters. In Uganda, we don't accept this. We are using the bracket. Then, here we put the values. You record the values here, like I've already shown you some. I've showed you some of them. Don't divide here. Do not. Please don't. Okay? Don't. Just record your values on every line. Those lines are already there in your papers. The answer sheets provided, those lines are already there. Ensure that you draw it using a pen. So it must be drawn in pen, in ink. Use ink, either blue or black ink. But you always ensure that you're uniform. If you're using black, use black. If you're using blue, you use blue, like that. I think that's all for now. Let me now go to the next part. We summarize and make this a little short. Now, how do you add the data or subtract the data in the main table of results? So I will emphasize that if they ask for x plus y, always ensure that what's being added or subtracted, the two, you have to put in brackets, then the units have to also be in brackets, like that, in centimeters. So supposing this is what we're supposed to get, we have already obtained those values, I'm assuming, and we're supposed to get x plus y in centimeters. When you're adding or subtracting, I told you that when you're adding or subtracting, what you have to bear in mind is that you deal with the number of decimal places of the different columns involved. The column of x has 1 dp. The column of y has 1 dp. Our answer has to be written to 1 dp, full stop. So our answers here will be written to 1 dp, and that's all. So you can go through and try this out. Add here, this is 16.5, 16.5. Add these ones, you have 26.4. Add these ones, you have 36.5. I think something like that. Here, have 47.0. Then you add 56. Good. Supposing I was supposed to write 56, but I was writing 36.0. Supposing that happens, and you don't want to cross out the whole table, and you've used the pen, what do? Cross through neatly cross through once. A horizontal line, a thin one, using a ruler, and then write that we had 56.0. You'll get your mark. Please don't avoid this thing. Avoid this thing. So what is this figure? You'll just fail. Then here when you add, we have 68.7, like that. That was a good thing to come up. There we've added, even for subtraction, the same story. Now life becomes a little bit more complicated for students when it comes to multiplication and division in the main table of results. And this is where I want to put a lot of emphasis, because so many students find hardships with multiplication and division. Please permit me to clear this table. I'm going to keep using these values here for purposes of manipulation. Now, we may be required to multiply or to divide some values or values of certain quantities in the main table of results. What do we do? So there is a rule that we have to follow. Actually, there are sets of rules. But I want you to mark the following. For multiplication and division, this is what we do. Please note it. Note it. So an example is, you may be required to get x squared, a column of x squared. Or you may be required to get a column of y squared. You may be required to include the values of 1 over x. You may be, x has to be written properly. If it disturbs you, write it like this, but ensure that it's small, not big. So 1 over x. You may be required to get 1 over y. Some people still emphasize that this has to be a 1. No problem. Still it is a 1. xy, you may be required to get xy. You may be required to get x over y. You may be required to get square root of x. And so on, and so on. So what do we do? When you are dealing with multiplication or division, ask yourself, is the resulting column the one that I want to get? does it come from 2 or 1 column? I don't know whether that came to you. I want to get x squared. Let me take an example. I want to get x squared. Values of x squared. Am I going to use more than 1 column, or I'll use 1 column only? The truth of the matter is you will use only values of x. So if you're going to use only values of 1 column, start by manipulating the biggest value. Oh, this is where people get problems. This is where students get problems. We want to manipulate and get x squared. Let me write it here. And the units will be definitely centimeters squared. We want to get the values here. Let me take another case. Maybe we also need x over y. Okay, xy. xy. Which will be also in centimeters squared. Like that. So what do we do here? What do we do? We ask ourselves one question. This is the question. This is the question. The question of the main table of results. Main table of results. The question is, am I using 1 column or 2 columns to get what I want? Am I using 1 column, values of 1 column or 2 columns to get what I want? Let me repeat. First even rub this. What was the question? The question of the main table of results is, if I am multiplying or dividing, I ask myself, am I using results of 1 column or 2 columns to get what I want? So, if I want to get x squared, how many columns will be involved? Definitely it's going to be 1. Only the values of x. So having identified that we are dealing with only 1 column, then now the next question is, in that column, which one is the biggest value? The biggest value in that column is 30.0. So you start from there. So I want to get the values of x squared. I will not start by dealing with this. No. I'm going to start with this one. I'm going to start with this one. So I'm going to say, okay, this is 30.0. The biggest. So I square it. What do I get? I get 99. I get 900. 900. I get 900. Now, squaring is the same as multiplying a number by itself. So it was 30.0 times 30.0. 1, 2, 3 significant figures, 1, 2, 3. So your answer should appear to 3 significant figures, and they are already here. So definitely you write this as 900. Now, after that, there are basically 3 questions. The last question is, how many decimal places does the value I have obtained have? It has no decimal places. So this value has no decimal places. So it dictates that since for it has 1 decimal place, all the values in that column should have no decimal place. Did I say it properly? No. Since this one has no decimal places, is just a whole number. All the values here have to be whole numbers. That's all. Did you pick that? I'm going to repeat with another one. So let's go. Now what is 25 square? 25.0 squared? 625. This one here squared is 400. This one squared 225. This one squared 100. This one squared. All written to 0 dps. Remember, in any given column, in any given column, the number of decimal places has to be the same. The number of significant figures can change. For example, this one here has 2 significant figures, this one has 3. What matters is the number of decimal places in a given column. It has to be the same. I'm going to repeat and do something else instead of xy. Let's look at a case of 1 over y. 1 over x actually. 1 over x. 1 over x. The units will be in per centimeter. Right? You see, write the units in line with the division sign. It's going to make your life a little easier and the work will be more organized. Like that. For me, I've written on the chalkboard, these values should be aligned. They should be aligned properly. This would have been a little bit up. This here, this here. Okay. I think it's okay. Now, I can shift them. Don't have to tease me. We had here 900. We had 625. We had 400. We had 225. We had 100. We had 25. Like that. Just like that. 1 over x. 1 over x. Remember the $1 million question in the physics practicals. It is how many columns are involved in me getting this new column. I want to get 1 over x. 1 over x. I want to get 1 over x. How many columns am I going to consider? I'll use definitely values of x, the column of x. I will not need 1 has no column. 1 is a float. Now there is a very big mistake that many students make. For them, there are those that say, first start by testing. No. I will talk about that soon. So, if I want to get values here of 1 over x, I will use values of x only. So it means that I come to the values of x, look for the biggest. The biggest is 30.0. So I will say 1 over 30.0. What does that give us? 1 over 30.0. On my calculator, it shows me that, where is the calc? Calc. 1 divided by 30.0. I have 0.0, then 333, the calling. So, remember this is what we call the float in lesson 2. Then this one has 3 significant figures, 1, 2, 3. It means our answer also has to appear to 3 significant figures. So, this one has no significant figure, this is not a significant figure, this one is not. So we start from here, 1, 2, 3, we stop there. So our answer is going to be 0.0333. So do we continue using the same rule for the next numbers? No, definitely no. What we do is, having obtained this one, we ask ourselves, how many decimal places does it have? Those are 4. So it means all the remaining numbers have to be written to 4 decimal places. It's that simple. 4 decimal places. So let's start. We start from here. 1 over 5.0. 1 over 5.0. Now we just use a calculator. 1 divided by 5.0. It gives you 0.2. You write 0.2 and then you add so that there are 4 decimal places. 1 over 10.0. That's definitely 0.1. So you add 3 decimal places. 1 over 15.0 gives you 0.06, recurring, so it will be 0.0667. Each one of them being written to 4 decimal places. Why are we writing to 4 decimal places? It's because the first one we wrote was to 4 decimal places. Let's go on. 1 divided by 20. What does it give you? 0.05. So you write 0.0500. Then 1 over 25. 1 over 25 over 25.0 equals to 0.04. 0.0400. You see that? That's exactly what you have to do. What you have to do. You always first ask yourself, the values that I want to get, are they going to come from 1 column or from 2 columns? This is either 1 column, for example, a column of X, or I will also need values of Y. If it comes from 1 column, celebrate. If it comes from 2 columns, then you ask yourself more questions. Okay, I think I will close that at that first part there. Let me look at the last 2 cases. What about if I want to get XY. I want to get XY. If I want to get XY, what do I do? XY. Definitely it will be in centimeters squared. You always write properly, my dear students. Or I might have X over Y, and that one will have no units. So XY, to get XY, it means you have values of X and values of Y. Now once you have that, the values you want to get are coming from more than 1 column, you do what you call testing. Look for the biggest quotient or a product. So check, do I get the biggest value by multiplying these 2? But definitely, since this is increasing and these ones are also increasing, the biggest values are here. We have 30.0 times 38.7. So what do you get? If you multiply here, 30.0 times 38.7, we get, I'm getting 1161. Yes, 1161. Now, big values, normally above 100, considered always to be above 100, you don't need to bother yourself. If you ever get a value which is big, above 100, write it as a whole number for multiplication and division. Yeah, but if you look at this, if we follow the rule, these are 3 significant figures, these are also 3. It means our answer would be 1, 2, 3 significant figures. Question, how do you rate that to 3 significant figures? Someone will write this 116. Oh my God. This is in thousands. Your answer is in hundreds. Remember, rounding off does not affect the number of decimal places. That does not even affect the place values. So it means that we have here 1161. We don't need to change the place value. Where there was a 1, because we have ignored it, you put a 0. But to make matters a little better for you and easier, if you ever get values greater or equal to 100, just write them as whole numbers. So for my case here, I'll write it as 1161. Why? It is a big value which is above 100. So I don't need to go into issues of considering decimal places. Sorry, significant figures for this case of multiplication. We just write it like that. Confused? No, you're not confused. I repeat, I said, if we are doing multiplication and we are using more than 1 column, first start by checking where you get the biggest product for the sake of multiplication. And if it's for division, look for where you get the biggest quotient. And we said if you multiply this by that, you get a small value, but the last ones give you the biggest value, which we got as 1161. And this is a whole number. It means that all the values here have to be whole numbers. They have to be whole numbers. So can we fill them? What is 5.0 times 11.5? It gives you 57.5. So what do you write? You write 58. Like that. Then definitely this is 164. Then here 15 times 21.5. You have 322.5. That is 323. Whole numbers. Whole numbers. Whole numbers. Then here, that is going to be 540. Then here, 25.0 times 31.0. That is 775, just like that. But we started by filling in the big one, the biggest. It tells us how many decimal places we are going to use in that column. Then lastly, x over y. X over y. How do you get x over y? You start by getting the biggest quotient. Where do we get the biggest quotient? Is it when you divide 5.0 by 11.5? Let's try to see. 5.0 divided by 11.5 gives you, for the first pair, 5.0 divided by 11.5, we obtain 0.434782 onwards. So these are two significant, don't worry about that anyway. Let's first test. Then we have 30.0 divided by 38.7. 30.0 divided by 38.7. We get 0.77, 519.37 and onwards. So what do we take as the biggest? Which one is the biggest? Definitely, this is the bigger one. So it means that we first manipulate here. Same story. So our value here is 0.7. Hold on. 3 significant figures divided by 3 significant figures should give you 3 significant figures. This is not significant. So we stop here. The next one is the one we stop there. 0.775 is what you get. And then you ask yourself, this first value that I obtained, how many decimal places does it have? It has 3 decimal places. It means every value here has to be written to 3 decimal places. So come back and check. What is 5 divided by 11.5? What do you get? 0.4347. So we can write 5. Because we have to maintain the number of decimal places. What is 10? What is 10.0 divided by 16.4? What do we get? We have 0.6097. 97. Okay, so we round off some interesting numbers. 0.609775. I want to round to 3 decimal places here. This is a 7. You add a 1, it becomes a 10. So we are going to write it as, so you write 0, you carry a 1. This becomes a 1. 610. Then we have here 15.0. 15.0 divided by 21.5. What do you get? Have 0.6976, that is 8. Then 20 divided by 27. What do you get? We have 0.741. Then 25 See, I don't like pronouncing that thing as 20, because the last time we pronounced it as 20, it brought problems. We have 0.806. So it means the biggest value actually was this one, not the other one. But you know, you can always look at the trend because of the errors that are made. You can always look at the trend, and still the principle will still apply, because this was the biggest, yes, but yeah, if you check through, still it works. It works, no problem. Okay, I'm going to leave with you some tasks. Someone may still be wondering, why haven't you put the units here? There are no units here. X is in centimeters, Y is in centimeters, so we don't need units there. We don't need the units there. Okay, now can you do for me this exercise? A simple exercise. Still using these very values. Using those very values, I want you to get for me the following. Get for me values of y squared. Definitely it will be in centimeters squared. Get for me values of square root of x. Definitely. The units, you also get them for me, yes. You get me the units, I will not give them to you. Then you also get for me values of x squared. Values of x squared over, no, we don't have x squared yet. You cannot have x squared over something without first getting x squared. Okay, 1 over y squared. Also, I want the units. Yeah. Table of results. Table of results. So, in case of any challenges that you may face, feel free to always comment. Drop a comment down. You drop a comment. And please share this material with your friends. There are so many students there who have been affected by the coronavirus. Oh, actually everyone has been affected, and it's the reason why some of us are taking time to sacrifice. I would have charged these resources so expensively for you to receive them, but I'm making sure that they reach you free of charge. Your excellence in physics is the greatest joy you can ever give me. So please share with your friends. You are free to donate. You are free to donate. You send me some money. Yeah, God will bless you for the things that I am doing. You can also donate and appreciate. My number where you can text, you can send actually your feedback on WhatsApp is 0775 374719. Please, this is available on WhatsApp. And please don't forget to subscribe to this YouTube channel. Some of us just watch, and when I upload new things, you miss them out. Please subscribe now, like now, subscribe to the YouTube channel so you won't miss any of the new videos. I wish you the best of the rest of the day. Bye bye for now.